Dear students, last time we discussed about the concept of de Broglie matter waves and whose wavelength is given by lambda is h by p or lambda is h by mv. Based on this equation, we have studied some problems, that is the wavelength associated with the matter wave such as an electron. It is already discussed in the last class. Today we shall look at some of the experimental evidences of de Broglie of matter waves. The first experimental evidence of the matter wave was given by two American physicists, Davison and Germer. The experimental arrangement is as shown in diagram. In this diagram, F is a filament heated electrically to emit electrons. These electrons are accelerated by high tension battery, and the whole arrangement is called electron gun and is denoted by G. The narrow beam of electrons is directed on a target P. The reflected beam of electron waves is received by a Faraday cylinder C, which is connected to the galvanometer G for the detection of electrons as shown in diagram. The Faraday cylinder is able to move on the circular scale S, and for a given accelerating voltage V, the scattering showed a peak in a particular direction theta as shown in the graph, with electron beam incident perpendicular to the crystal surface. The scattering direction was found to be 50 degree for electron accelerated to 54 volts. Under these conditions, the surface rows of atoms acts like a ruling of a diffraction grating, producing the first order spectrum of 54 volts electrons at theta is 50 degree as shown in the diagram. Since the target is nickel, whose interatomic distance is about 2.15 into 10 to the power minus 10 meters. That means the interplanar spacing D is 2.15 into 10 to the power minus 10 meters. Sine 25 degrees 0.09 into 10 to the power minus 10 meters. Using this in a Bragg's law, and for a first order spectrum, n is taken as a 1, therefore we get 2 into 0.909 into 10 to the power minus 10 sine of 90 degree minus 25 is equal to 1 lambda, 1 means n is equal to 1. Here angle theta is the angle between the incident beam and the interatomic plane as shown in the above diagram. Therefore, here the lambda is found to be 1.65 into 10 to the power minus 10 meters, or which can be written as lambda is 1.65 angstrom units. According to the theory of de Broglie concept of matter waves, for a practical results, when the electrons are accelerated to about 54 volts in this experiment, we get lambda is equal to 12.26 divided by square root of V. The square root of V value is nothing but square root of 54, whose value is found to be 1.67 angstrom units. These two values are in good agreement, hence it confirms the de Broglie concept of matter waves. This is one of the experiment for the existence of matter waves. Let us look at the second experiment, that is known as G.P. Thomson experiment. G.P. Thomson performed experiment with electrons accelerated from 10,000 to 50,000 volts. He determined the wavelength associated with electrons. The diffraction patterns are only possible if the waves are associated with particles. The experimental setup is as shown in the diagram. The high energy electron beam is produced by the cathode C. The beam is excited with a potential up to 50,000 volts. A fine pencil of this beam is obtained by passing it through the slit. Yes, the accelerating fine beam of electrons now falls on the thin film, which is denoted by G, which is of the order of 10 to the power minus 6 centimeters and which is made from gold or aluminium. The photograph of the beam from the foil is recorded on the photographic plate P as shown in the diagram, and the photographic plate is denoted by the letter P. The whole apparatus is exhausted to a high vacuum so that the electrons may not lose their energy in collisions with molecules of the gas. After developing the plate a symmetrical pattern consisting of concentric rings about a central spot is obtained, which is as shown in the diagram. The observed rings can only be interpreted by considering that the diffraction pattern of incoming beam is due to diffraction of electrons by the gold foil G. As the diffraction pattern can only be produced by waves and not by the particles, so Thomson concluded that electrons behave like waves. Thus, Thomson experiment clearly demonstrated the existence of matter waves. These are the two important experiments for the existence of matter waves or the verification of matter waves experimentally. One is Germer and Division and Germer's experiment, and another is G.P. Thomson experiment. Okay, in the next class, we shall discuss about the Heisenberg's uncertainty principle.